Hi guys. So in this video, I'm going to walk you through how you can use Google Sheets to create response curves. So this is a method that I actually use with most of the clients that I work on. And as you can see in front of you, this is basically a revenue plot, MER revenue plot. So all you need is basically three columns for this. You need to start with ad spend, MER, which is the marketing efficiency ratio, and you should be giving the blended MER here, and then the contribution margin. So this can be your CM1, for instance. So this is going to be a completely automated sheet, but before I jump into that, let's just quickly touch upon what exactly is a response curve. A response curve, which will look something like this. So this is going to be the output. As you can see, there's going to be ad spend here, and you will have in the x-axis and revenue and profit being plotted along the y-axis separately. So this is basically a response curve, and this gives you how revenue and profit are changing with respect to ad spend. And the very reason why this response curve consists of both revenue and profit is because both of them matter. It's not just profit that matters, but also revenue, and certainly not just revenue, but certainly also profit. So this is the rationale behind doing this. This is basically called a response curve rather, how the outputs change with respect to changing inputs. That's as simple as that. Now, all you need to do in this case is I'll just get rid of this output sheet here. So you'll just have to come to this part here in the menu bar, which says visualization tools. You have to click on this, click generate enhanced chart, and then it's going to start doing its work in the back end. There's an app script that's running in the background, and it's going to create the chart here for you. So you can see what's happening is the blue line is giving you the level of profit, but the green line is the revenue, and you also have the MER that is being shown. So clearly, as you can see, the profit is slightly a downward slope. As you can see, it's probably not very clear because the profit levels are very low in the data set compared to revenue. The profit margins are low. But you can also see that the MER is also going down as the ad spend is changing. So this is not necessarily an increasing ad spend here, but this is something that you should be doing for better visualization. So you can actually have the ad spend in a descending or ascending format. Rather, you should be putting it in an ascending format. However, this is basically a monthly visualization. So you're trying to understand, for instance, on a month-on-month basis, how the ad spend or on a certain weekly basis or whatever time periodicity that you're taking, how the MER has been changing, how the contribution margins have been changing over that time period, and then you just create the response curve as an output. So that is basically what this does. You need to dump the values of ad spend and MER and contribution margins from wherever you have the data. So this is basically the chart, and this chart was also created. This is called the profit curve, and I'll just show you how this was generated here in Python as well. The additional things that you can see here is that we also have the max revenue and the max profit being pointed out here. So this is the point at which the revenue is maxing out. It's the peak, and then this is the point at which the profit is being maximized, and therefore that has also been pointed out. Now, this is a response curve in relation to the data set that you have uploaded. You have to understand that this is not purely the response curve because a response curve is actually supposed to also have a model behind it. This is simply plotting the curve. Now, the profit curve is actually a response curve model, and that will basically try to give you an indication of the future. So that's the difference between a regular plot and response curve. So even if this is actually a response curve in strictly speaking, because it's giving you still the responses to the ad spend, but it does not tell you anything about the future, right? Not immediately from here anyway. So what we will require here, and this I've already dumped here, although this was not created in Excel. This is, for instance, the regular response curve that we are familiar with. This is using something called a logistic function. And a logistic function or a logic function, these actually follow a certain kind of exponential equation. I'll just come to that in a moment. And this is an S-shaped curve. So an S-shaped curve means that initially there isn't much of an impact of the change in ad spend, and then suddenly there's an increase and then it reaches a saturation point, and then it just sort of stagnates. So that is basically how ad spend can impact anything. It's this conversions and this dummy graph, but it can be profit or revenue. So this is kind of an ideal scenario. This depends on certain parameters, which I'll just show in a moment. But this is actually the outcome of another data set, which is sort of a real data set where it's not exactly a data set. You only input the user inputs only a couple of numbers, and this is how the value has been has been obtained in terms of the response curve. So if I actually come to the way that was prepared, this is the way that response curve was created. As you can see, it's a logistic function. This is within Python. And you will see that there's actually this particular equation here, which is the return from X conversion. So this is the most important part of the entire thing that's going on here. It's a very mathematical piece of Python, not very complicated, but you don't have to understand the Python, you have to understand the response curve that I'm talking about. This, by the way, is not doable just by plotting on Google Sheets alone. This has to be done through either some tool or through this sort of a coding approach. So you can see what is being done here. Like I said, so NP is numpy, but it's simply 1 plus e to the power minus 1 into this thing here, spend, which is spent by the spend minus saturation spend. So this is returning this value, maximum conversions in the numerator, and this is the denominator. So I'll show you the equation that's actually that is getting derived from. So this is basically related to the concepts of logit and sigmoid functions, which are basically inverse of each other. So you see that something called the odds. So this is, suppose the odds is p here, and you have p minus 1 by p. So if you look at the logit function, this is nothing but the logarithm of the odds. So you have the value of x, which can be spends here. So logit x is log of x minus 1 by x. So that's the logit function, and this is how it looks like. Okay. And the sigmoid function looks like this because this is the inverse of this function. So we were basically looking at the sigmoid function. And the sigmoid function, as you can see, is nothing but sigmoid. When you apply it over the logit model, it gives you back p. Okay, so it's kind of like taking the logarithm of an exponential function, right? You get back the value of x. And this is how it looks like. It looks like sigma of x is 1 by 1 plus exponential minus x. And that's exactly what's going on here. If you look at this function here, that is the function, that is the way this has been done. So what this actually means is that you are trying to get to that particular value of spend for which the maximum, the number of conversions is half the maximum number of conversions possible. Let me say that again. You are trying to get to that level of spend for which the number of conversions from that model is going to be half the maximum number of conversions possible. And that for a logistic or a sigmoid function like this is at x by 2 or is cost by 2. So what this does here, it actually takes inputs from the user for the number of for the cost for the number of conversions in a certain period for which the spend has happened, and then the break-even CP. So all these things should be there with someone who's running the campaigns or running the business, and based on those, it will define the maximum conversions, and it will also define the saturation saturation spend as cost by 2, like I was saying. So it's basically simply half the total amount of cost, or the half the cost basically. So that's pretty much how it works. That's the fundamental principle behind it, meaning that if I just jump into the curve again, so if I look at that saturation spend, as you can see, the saturation spend has been taken at the half the level of spend. Okay, so it goes up to 2000 here. At 1000 is your saturation spend because it assumes that the maximum number of conversions possible is going to be around that point. Okay, and this of course is an approximation, but it's generally a reasonable approximation, and depending on how good that approximation is, the curve will take this S-shaped form. Now, I use this data, of course, there's no real data set, like I said, there's only an initial cost, there's conversions and break-even CPA. Based on that, the calculations have been done by this particular response curve model, which is, of course, following this particular formula here. And you can see the output that it gives is this one. So this is actually a logic function. This is a proper logistic function or Sigmoid function response curve. And you can see that this has kind of an S-shaped thing appearance to it. So you have to understand that not always in reality will the response curve look like this one that I just showed. It will not always have this kind of an appearance. It might have this kind of an appearance as well. And this actually depends on another factor. This depends on a factor here. This little thing here you can see here which says -1. This basically is your is a factor which is called K. So that K will determine the steepness of the curve. So if the K is on the higher side, the higher is going to be the higher is going to be the steepness, or the steeper is going to be the curve. That is one thing. Also, it depends on the other factors like at what point you're taking the saturation spin. So these will determine whether or not the curve is steep, and the K is simply the point at which it starts to taper off, meaning the the additional inputs are not having as much impact on the output anymore. So that also is related to the concept of marginal CPA, as you can understand, because it means that the marginal CPA is getting higher, or you are basically not getting marginal outcomes for each additional units of the input. So that is basically what this profit curve is all about, and you have to understand how this works. One is simply plotting it based on data, and the other thing is to also generate an understanding of how it will work over different ranges of values. So you, for instance, would have provided in this model a value of 1,000, right? So this actually, rather in this case, it was provided as 600. As you can see, these were the values that were provided: 600, 55, and 40 for each of these parameters. And based on that, it provided a future prediction, sort of a response curve output. So this is one form of response model, okay? And this is not the only kind of response model. There can be so many other kinds of response models. There can be the Hill equation, there's the Cobb-Douglas equation, then there can be the Paolo equation, quadratic equation. So you can use so many types of methods to actually arrive at these things. You can even use regression. So it's important to understand that that there are multiple mathematical approaches to arriving at this, and each has its own pros and cons. So this has its own limitations as well, but this is one approach, and it's a very, very common approach. But yeah, this is just something that I wanted to point out, that when you are actually plotting something, that's a reflection of what has happened so far in the past. But if you're also interested in knowing about the future, if you want to predict, then you should move to a response curve thing. And there, the question of choosing the model becomes very important, and that's where the applications of data science come into the picture, which is not always as simple as things would be. But anyway, if you want to start at least with the plotting, this itself can take quite a while to plot. As you can see, it's nicely shaded. The green area represents the revenue, the blue area represents the profit. You have the max revenue, the max profit. So you can use this particular tool here. This is a DFI one-click GSheets tool, and it will get the thing, get you started at least with the plot. And I hope you have understood also what response curve model is all about. If you have questions, feel free to comment. And yeah, do like, share, and subscribe if you like the video. And I'll see you in the next one. Thanks for watching.